That can be done in part by y'all helping us. We do have a thing called ACM San Antonio, or ACM SA membership. The associate membership is more just we like to see you coming along, and we'll have a sign up for that in the future, just so we have people participating. But the other piece is a full member. Full member gets access to our ACM National Access catalog, essentially. You get access to ACM National resources, currently discounts on our future workshops and upcoming workshops. And that's a yearly subscription. So excited to be offering 50% off of that right now until June, the end of June. I'm just going to say the end of June because I don't remember the date right now. And if you're interested in that, definitely hit up those QR codes or find us on acmsa.org. Additionally, you can also follow us and keep up with all of our meetings happening all the time. Those happen pretty frequently. We try to have a general meeting every other month, but this month is definitely a busy month. More to come after the meeting, but keep up with our events on Luma, Meetup, or join the tech community at DevSA with our Discord link here as well. But like I said, want to get this kicked off. Excited to introduce Gene Tigner for our last day in person over Advanced JavaScript. So thank you, Gene.
Hello. Let me switch this out. Give me a second. There it is. So far away. Click. Okay, and then let me pull up my slides. And do this number and presenter view. And then we're going to pull this over here. And we will make it full screen. All right, cool. All right, so today we are going over advanced JavaScript prototypes and inheritance. So last time we went over some objects basics, what are they in JavaScript, how can you define them, and some small tricks that you can do. But here we're going to go further into prototypes, specifically talking about prototype chaining, why we use prototypes, why JavaScript leverages those versus how other languages leverage class-based structures like Java and C# and stuff like that. And then we're also going to talk about inheritance. So let's get this started. Real quick, a little bit about myself again. If anybody is joining that's new, I'm a UTSA alumni, graduated in 2020. I have 5 years experience doing enterprise software engineering, and then also 5 years experience doing JavaScript and TypeScript. I do keep those two separate because I haven't been doing only JavaScript this entire time. I've also had experience doing Unity development, and I've used a different number of different languages. So moving on here. So in JavaScript, why prototypes? So unlike class-based languages, JavaScript leans on prototypes for inheritance. This allows multiple objects to share behavior without duplicating code. So here for these 3 bullet points, JavaScript uses prototype-based inheritance, enables objects to share methods and properties, and then improves the memory efficiency and encourages composition. We are not going to be really going into too much of the memory stuff. We're just going to be looking at objects as a whole, the prototype chain, and some class-based stuff this time around. So the prototype chain. All right. So when you access a property, JavaScript checks the object first. If not there, it checks the object's prototype and so on. This is prototype chains in action. So basically what this means is if you have an object that has a prototype, that has another object that has a prototype, that has another object that has a prototype, if you are referencing that last object in the chain and you want to access a variable on its parent several steps up, you don't have to go digging around for it. You can just reference that variable on that child, and if it is in that chain anywhere, it will find it and it will present it to you. So what does this look like for us in code? So let's take a closer look here. So here's an example that I wrote earlier today. So taking a closer look, so JavaScript looks at properties directly on the object. If not found, it checks the object's prototype, and then it repeats that until it gets to a null state. If not found, it will return undefined. And then I have written here that every object in JavaScript has an internal link to another object, which we just discussed. And let's just take a look closer at that. So, extreme prototype example here. I have this constant that I've named gremlin, and I've assigned it to an object.create of null. When you try to gremlin.toString on this object, you're going to get undefined because there is no prototype. If you use object.create with a null value, it's going to create a new object, and in place of gremlin's prototype, it will inject that null. Why is this important? Let's go forward, find out here. So if we don't do a null, but we do some chaining here. So we're going to do an object.create, and in that we're going to pass in another object.create, and in that we're going to pass in a third object.create here. This is something you probably won't see in code. It's just something fun. So get your mind wrapped around this chaining sequence. So here, the object that we're creating is just an empty object, and then we're passing it through, and then so voidling here is going to have a prototype of an empty object that also has a prototype of an empty object that also has a prototype of an empty object, so on and so forth. I have here written, is that the correct one? So object create null from that last one creates an object with no prototype at all, which is useful when you want a clean slate, no inheritance methods, no toString, and not even a has-on property. And we'll talk about has-on property later. Moving on. I feel like I'm going way too fast here. So here's a really extreme case. So let's say I have a constant called root, and I give it an object with a variable or a property of power, and I set that to true, so it's a Boolean. And then I have layer 1, and I do an object create, and I pass in the root object, and then in that layer, I go to layer 2, and I pass in layer 1, layer 3, layer 2. So here, if I console log layer 3.power, even though layer 3 technically hasn't been defined as having this shape, it still goes all the way back up this chain. I don't know if you guys, here we go. It goes all the way back up this chain, and it will access this power variable. So let's, given that logic there, let's take a look at our first question for today. What would you say that the result of this expression is? Don't really worry about has-on property right now, just kind of infer using your own logic. The people in this room, what would you say the console log will print out to the console? True or false? True. Sure. True. Good. So how about this one? If I create a constant root and I give it an object of power, and I give it a string power, and then I make another constant layer 1, and I give that object create root, knowing what we know from the previous slide, what will we say that would be printed out if I said console.log layer 1 that has own property power? Would you guys think that layer 1 would have that property or not? Yes, true or false?
Can you go back to the previous slide?
Here's the previous slide.
Thank you.
We just said this was true.
Oh, can you show us the definition of create?
Can I show you the definition of create? Later.
Okay, never mind.
I can show you the definition
Okay,
of
I'm going
create.
to blindly say
I'm gonna say true.
true.
This is actually going to be false.
Of course.
Yeah.
Depends on your definition of own.
So, I mean, if you want, you could argue, okay, so if we think about it this way, root is the parent in this scenario. Layer 1 is the child of the parent in this scenario. The child is going to inherit whatever the parent has, but it won't actually have it itself. So if I was to show you how these objects looks in a console, and I can do a JSON stringify in a moment to show you, but you'll see that the layer 1 object, if I was to print out that object and all of its properties, it wouldn't have it wouldn't have the variable power on it. It would have power on it as a prototype inside of the root object that's associated with it. It's kind of a little bit backwards to how you would normally think about parent-child relationships, since it kind of goes this way instead of this way. But here, let's actually, this will be a good time to take a look. So let's pause this for a moment and let's go, where's my mouse? Where's my mouse? Here it is.
So it has own property is looking in its own prototype layer.
So let's actually go to the next slide real quick, and then we'll go to the example that I have. So object that has own property versus inherited properties. So has own property will check only the object's own properties. So it's very literal. An object has properties or it doesn't. And whenever you use the create method, it's not really creating a copy of that structure. It's just assigning the parent to the prototype. So it's, in this case, root is being assigned to the prototype hidden property in the object. So here I have written, excuse me. So here's a bit of code on the right here. You'll take a look at console log kind in Gremlin. So up here we've defined this variable kind. It's a creature. So whenever console log kind in Gremlin is printed, it'll say this results to true because the Gremlin, its entire structure, including its prototype, does have kind in it anywhere, and that's what in will do. It'll give you, if it's anywhere in your chain, it'll come back true. So, but here gremlin.hasOwnProperty kind is false because the child gremlin, the child gremlin does not have the parent, in this case base, doesn't actually have kind on it. So let's take a closer look in code. Boop. Where's my IDE? Boop. And then we're going to switch real quick to this. And we're going to go here, and I'm going to make a new, JavaScript file. We're going to do example 1. And in it, I am going to bump this up. And let's just copy what I had down. I think I have an example here. Give me a second. So we have some object, so const obj. I'm going to call this one parent. And we're going to say that parent has some variable on it, say name, and then we're going to say parent. And then I'm going to say child, and I'm going to say object.create parent. And then we are going to console log JSON.stringify, and we're going to stringify child. Actually, that might not work because I think, no, let's do it this way. Let's do console.log child.name. Oh, no, that actually works. So that makes sense. .log JSON .stringify child. So if I stringify the child here, oops, that is the wrong folder. Example 1, run example 1. So you'll see here on the right, it resulted to an empty object. So it's showing us that child doesn't actually have directly on it what parent would. So if I console.log JSON.stringify parent, this should come back with name parent. But I'm still able, how am I still able to say child.name? And why would it come back as parent here? If we take a closer look of console.log, let's see, child.proto, it should give us back this same object. And it does. So what's happening here with child.name is it's inheriting that name from its parent through the proto. And this is how you would access that proto. Any questions there? It's a little weird to wrap your head around if this is the first time you're seeing it. Because like I said, it kind of feels like it grows out than it does in, like a child coming out of the parent instead of the other way around. But okay, so let's go and move on. Let me use this and go back over here and stop mirroring. Okay, cool. Back to notes. Where did my, there it is. All right, moving on. So I know last time we did talk about constructor functions, but there is more to say here. So whenever you have a constructor function, dot prototype is a property on all functions. So when we use a function as a constructor with new, we can attach shared methods to its dot prototype. This way we can avoid redefining functions every time we need a new object and whenever a new object is created. So kind of think about this in this way. You know, whenever you make a class and you want to give a function to that class that is something that every class will ever use, you can do that in a similar way with constructor functions by assigning anything back to the prototype. So here in this example, I have dog.prototype.bark, and then I'm assigning it to a function, and then that function is just console logging the name of the dog and that it barks. So whenever I create a new dog here, so in this example, I have a constant Fido, and that's equal to new dog, and I give it the name Fido. And then Fido.bark would then print out Fido barks. Very similar to how we would do it in a class. In a class, you would define the class, you would create a constructor for the class, and then you would have a function defined in that class. That way, whenever you create the class and then call that particular function in that class, it would act the same way. So new sets the object's proto to the function's dot prototype. This is actually pretty cool, explicitly because when I was creating this course, I didn't really know this. You can define this at any time. If you have this function dog here, and you're like, you've been using dog all over the place, and you're like, oh, I need another function for it. But I need it for every instance of every dog that has ever existed. Oh, dog.prototype whatever I want equals a function call. And now every instance of every dog that has ever been created by my software has that additional function. Okay, so the new keyword. So here you'll see that I use const Fido equal new dog. You usually see that whenever you are creating classes in like Java and stuff like that, right? So if you have a class in Java, to create a new class, you would use the new keyword, correct? Or a new instance of that class. Well, here, new is kind of a shorthand for 4 specific operations that are happening in JavaScript. So I have here written, it's 4 simple steps that build a new object, wire up the prototype chain, and hand control back to you. So here on the left, it creates a new empty object. It'll set the proto to the constructors.prototype. It'll call the constructor with this bound to new object. So when I say this, I'm using the this keyword, excuse me. And then it returns a new object unless another object is returned explicitly. So now I'm going to go back to a demo, and I'm going to demo this specific capability because I want you guys to see in code how this is the same thing as using just new alone. So go up here again, switch back over to this, and I'll get this down mirror. Okay, and then we're going to go to WebStorm. And we are going to go to another new JavaScript file, and I'm going to call this example2. And in this one, excuse me, I'm going to define a new constructor function. I'm going to call this person. So let's see, person. function person, and I'm going to give it, let's see, name and age. That's fine. I'll let it autofill. So this dot name and this dot age. And then if I do const person1 is equal to new person. Okay, so what does that look like if I just use new? So I'm going to say, excuse me, I have an example written down here. Const, I'm going to call this person2, and I'm going to set this to an empty object. And then I am going to set person2 dot underscore proto, and I am going to set this to the person, so the function that I made above, person dot prototype. This will right. Okay. And then I'm going to run a call on it. So person. So now I'm still referencing the constructor function, but I'm doing a call on it, and then I'm going to call. Excuse me. Let's see. Name. Actually, let me just double check I'm doing this right. Okay, I need to reference the person2. So reference person2 in the call function, and then give them a name and an age. So here, Bob25. And that is going to do the exact same thing as new would. So here, if I console log person1 and console log person2, they have the same structure. But how do we know they're, oops, hold on. How do we know they're actually doing the same thing? Well, let's see. I have another example. Give me a second to take a closer look. So let's write a couple things to prove that these are kind of the same thing. So if I have a console, let's do a console log, and we're going to log person1, excuse me, and we're going to do the proto on that one, excuse me, and then we're going to check for equivalence on person2 dot proto, and this should result to true. So let's go ahead and run that. Yep. So what's happening here is I'm showing you that the protos are the exact same. And if the protos are the exact same, that means that they're both using the same proto configuration from the person, the function here, which makes sense because we're using it to define prototype here. And then this is basically just doing the same thing as this, but it's shorthand. Any questions there? No? Straightforward?
Do you get like a memory save out of this, or is it any benefit to like doing it one way versus the other?
That's a good question. I'm pretty sure there probably is. I don't know the answer to that one, but I'm pretty sure new has memory efficiencies built into it versus just doing it yourself. But it's good to understand kind of what is going on behind the scenes, just in case you run into any weirdness with your own code. Like, why is new behaving this unexpected way? Oh, okay. Okay, so let's go back to the slide deck. 21 minutes. Okay. Oh, can I just do that? Oh wait, but I need this. I need their notes. Okay. Bob. Nope. Okay. Moving on. Now we're getting to your question. Object.create. So object.create, I think the name of the slide is wrong, but anyway, so it creates a new object with a specified prototype. No constructor function is needed. It's also useful for lightweight inheritance. So you remember earlier when I was using object.create, and inside of that I was using object.create, and inside of that I was using object.create. That is like a really good way. That's what it means by lightweight inheritance. I'm inheriting in a chain in a lightweight manner. So object.create is a cleaner alternative when you just want to make one object inherit from another. let's see, do I have, so in this example here, I have a constant of base, and in that I have a function that I've defined called greet, and in that function, it prints out a console log pi. I then will take user, I'll make another user, so const user, and I'll set it to object.createBase. And again, what we just talked about earlier is that this is doing the parent-child relationship thing where user is inheriting the capabilities of base here. So I set user.name here, and then I also have, I don't have to attribute myself to the constraints of my parent. I can do whatever I want with the child user here, and it'll include it in its own properties. And then user.greet here will just print hi, because again, the child
user has access to the greet function, but it's not its own.
Yes, that is correct.
Just like a kid.
This is a knowledge of just like growing up, isn't it?
Right.
You get all the knowledge passed off, and then it's all yours.
So question, can you change prototype?
Just
on an
directly?
object?
Yes, you can.
So an object isn't permanent.
No, it's not.
Ooh, that's very different.
Yes,
from
so if I
most
wanted to,
object-oriented languages.
I could overwrite. Yeah, JavaScript lets you be very flexible, and it lets you overwrite anything you really want to overwrite.
Yeah, run even the standard prototype.
Yes, even the standard prototype.
So if I was to do that, then if it was inheriting any of the fields, then they would lose those as well as the functionality.
You would lose the inheritance from the prototype chain. Yes, if you, depending on where you interrupted the chain, but yes, and what you're trying to access and how deep of the child into the relations you're
And
trying
then
to
if you
go.
put it back, you're
You,
going to be accessing different memory or the same memory?
that's a good question. It depends. If it's the same original object that you're assigning it to in the memory stack, in memory, then I would assume it would be the same. You would get the same inheritance. But that's a good thing. We could try. Let's try that. Let's break into that real quick. That's a good thing to look
Object's
at.
permanent. It's like, oh my gosh.
So let's do
This is
this.
quantum computing.
That's a good experiment. Let's do that. So let's do this. Back over here, let's go to WebStorm. I'm just gonna go ahead and use the same example file. So I'm gonna, okay, let's do this. Let's say, I'm gonna rename this to parent. I'm going to say const child first gen. Don't do what I just did. No snake case. First gen, and then we'll say that is equal to object create, let's just do parent. No, I have to define a parent first, that's right. So let's do const parent is equal to a new parent object, and then we're going to copy, we're not gonna copy, we're gonna inherit from the parent, then we're gonna do a second generation, copies from the second child, a third generation, and let's do a third generation too, just for laughs. So const child third gen, and then we'll do a console log, and we'll do child third gen, and then we'll print out the name, and that should print the name of the parent. So it should print parent. So let's do run. Yep. So we got parent. So let's interrupt that inheritance. Let's look at, let's see what happens when we interrupt it at the second generation. So let's say child second generation, and then we're going to access the proto, and we're going to change it to, let's change it to an empty object. Let's then try to access this again. It should be undefined. Oops. Yep. So I did interrupt it, but let's see, we want to put it back, because your question was, can we get it back to that original state? So let's do that. Let's see. So let's do child second gen, and we'll do proto. And in this one, we had chained it through the first generation, and the first generation got its proto from parent. The second generation got its proto from child first gen. So let's do that. Child first gen. And if I'm doing this correctly, third gen should come back to parent. Yep.
Yeah, but you haven't changed that on
What do you?
child third gen yet, have you?
I have not touched the child third gen. No.
No.
The reason I went with the second gen is to show the chaining that's happening.
No, yeah, I get that.
But okay, so you want me to change the child third gen?
No, I just want to, because if you were to change on child third gen, if you change name to child.
Ah, I see what you're saying. So if I go to child third gen and I do dot name and I set that to child. And then if I do console.log, wait, you like the parent or the child?
I want to see his child, yeah, his name.
Child. Well, he doesn't actually own name in this instance. He has access to parent's name, but he doesn't own it. So he doesn't get his own name. In this instance, he doesn't really get his own name. So if I was to do child third gen dot name, it'll be child. But if I was also to do parent here, maybe I'm wrong. Maybe I'm wrong.
Yeah.
It's good to be wrong. Yeah, no, you're right. You're right. You're absolutely right. You're absolutely correct.
But now if you were to break it,
Now break it. Okay.
yeah, do what you did before.
So if I was to
Set part of the empty object and then reset it.
And then break those two again.
you want me to break through child or second gen or third gen?
The same
Second
thing.
gen. Second gen. The same way I did it before. Second gen dot underscore proto, and I do empty object. So I break that chain, and then if I try to console log
it again.
child third gen dot name.
Still only has reference.
I don't know. My AI says it's going to be child, but let's see what actually happens.
Yeah.
Oh, keeps it as child.
Because you've now set it to child,
Yeah.
and it's on this, you overrode the name,
It
right?
has its.
But if you're sending away the prototype, then you know.
You no longer have access to it.
But I bet you, so do a has own attribute for child third gen. I bet you it has its own attribute now.
Console.log
Because we now deliberately
child
set it rather
third
than
gen
the
dot
inheritance.
has own property name. AI says
Your
true.
inheritance is to get the structure, not the value.
Yeah.
Right?
So let me see.
Now you overrode. the
I'm going to
parent.
take this and I'm going to go above here before I've set this. You're right. This actually wouldn't make a lot of sense here. So if I did that, yep, it's false. And then we set the name to child and it becomes true because it gets its own property.
Oh, the AI inserted the comment down below.
Yeah, my
Yeah,
AI
you
is trying to
copy it.
infer.
Okay, that's, the AI didn't,
So
the AI is not mistaken there.
yeah, the AI is
There you
not,
go.
not so. Yeah. Okay. Good point.
So it creates the instance of the attribute when you reference. Good grief.
Well, I mean, this is me assigning here. I referenced here.
Yeah, I know, but
But I
you're-
assigned
all you're
here.
doing is references places in memory, right? So,
Essentially,
Yes. Yes.
so somehow it's pointing to somewhere else.
Well, I mean, so a string literal here gets its own because JavaScript uses every time you create a string literal in JavaScript, it's immutable and it's in its own spot in memory.
Yeah.
So yes, you're correct.
What if you restored the prototype?
Well, isn't it because like on line 22, when you do the dot name, even if it doesn't have it, JavaScript will just create it for you, right?
Yes. So what happened here? This.
Oh.
Yes, you're correct.
So-
So even if this chaining didn't occur above it, so if I was to get rid of the third gen here, no, the object directory. So if I was just to create this as an empty function or empty object here, child third gen down here, because I'm dot name, would inject name into that empty object.
Okay, so a different example.
Different example.
Let's say
Okay.
I had a method on my parent.
Okay, let me get rid of some of this, and then let's put it back this way,
Yeah,
and then
this is
let's on the parent. Let's
Let's
make
put
a
parent.
method.
Yeah, put a method which is,
Let's call it get name, maybe function.
okay, folks, yeah, that's good.
Okay,
yeah.
so
now you can call get name on child third gen.
okay, so let's do console.log. Actually, you know what I'm going to do here is instead of returning this, I'm just going to console log it so that I can do something quicker. And then instead of doing console logs down here, I could just do child third gen dot get name.
Typo.
Where?
And as the sergeant at arms, I want to just let you know that it's 7:06. You have 24 minutes.
Okay, thank you. So here it printed parent. Okay.
Okay, so now I'll set,
Child third
Oh.
gen.
no, now obliterate the second gen from the proto.
Obliterate the second gen proto.
Yeah. Like you did before.
I'll try that out.
Because if you take him out of the prototype chain, it shouldn't have to function, right?
Right.
Because he's inheriting.
If it inherits that function, that should no longer inherit it.
But the get
Yeah.
name's only reference to the photo, so it's
That's
only
what I-
gonna get
Oops, I need to print it again. So child third gen dot get.
Typo again.
Putting him under pressure here.
I-
No, maybe we are, I'm just saying.
I got a type error. Child third gen dot get name is not a function
Yeah, as we would expect.
because we've
So
blown
if
it
you add it
away.
in,
So
okay,
yes,
so
so
what-
I could theoretically go in here and do this
good, that was the way we would expect. it,
It's
right?
sane.
dot
Yes.
dot excuse me.
And good catch on there that it actually creates,
Yeah.
because JavaScript dynamically.
So
gives
I want
you
you,
attributes,
can you
right?
try to do like overwrite dot name after line 15 to see if it adds it to the structure itself or if it. and
Do
then
you
get
want me
name
to
set
do
dot-
child?
So do child third gen dot name equals and then set it to something. And then try running the function again, dot get name.
Are you trying to? Are you?
It's still gonna error out because the chaining has told us that we no longer have access to get name.
it
So
looks
if I
at
do
the
this,
Third gen.
Sound of
It
function.
says get
function,
name.
and it goes up the chain.
so we get parent from this,
Yeah.
we set this to child, and then we try to call the get name function again. It doesn't exist
Well,
anymore.
no, without line 19.
Yeah, comment out.
Oh, get rid of line
Yeah,
19?
yeah, because I want to see if
It should
if
print
NA
child.
17 is creating the or adjust or what's it called, modifying the structure of it. So when we get name again, it references that function above. So it might not know that.
Yeah, but we're
child-
using, but we have the this keyword here,
Okay, never mind. Yeah.
so that this keyword
Okay.
is key here in that regard.
Okay, let me ask you a question. So, third gen inherits the name attribute from an ancestor.
So yes, so third gen will inherit it from parent.
Can you assign a value to the name attribute via the third gen object?
I'd have to go through the proto. I'd have to dig into the protos to
So
go
the
change
proto
that.
would have to have a setter.
Almost.
You know what? There is something I could try here. I was gonna hold on to this to the last of this, but let's try this. Third gen dot set. No. Set prototype of child. No, that's the prototype.
Create a new object.
If I have a reference, if I have third gen and I want to set the value of name to the if I want to change the ancestor's value, how can I do that through third gen? Because if you say child third gen dot name equals, it's going to give it its own property of name.
Mhm.
And it will lose that kind of direct access to the ancestors.
See, I'd have to go through the protos.
Yeah.
Okay, well, that makes sense. That makes sense. It's ugly as hell, but it makes sense at least.
You're probably not double chaining everything though, typically.
I mean, in a real world environment, I wouldn't do that ever. Like, 'cause that's just insane.
But still, I mean, this is stuff that we can come across. that-
Yes, you're correct.
Pull my hair out.
I
You're
mean,
correct.
it's just basic in MDN though. Like,
Yes.
Our existing prototypes are like proto, like several layers deep. You ever go pull those things apart? They look nasty sometimes.
All right,
So you're,
go ahead.
Question.
you're inheriting from instances.
Yeah, I mean,
I thought
Yeah.
you wouldn't get data.
say again.
Mhm.
You're inheriting the structure and the function calls, right?
Yeah,
So
they,
that's typical inheritance.
they don't
But if
have,
you're pulling data down, then that's not inheritance,
Yeah.
that's something else.
so JavaScript, JavaScript's idea of classes really are
Yeah.
based on objects.
It did call using object or create this way. It did say in my notes on the slides, excuse me, lightweight inheritance.
Looks different than you.
So it is,
Yeah.
you are correct. It is different than normal inheritance.
Okay, good.
Just a term.
I'm assuming it's lightweight because it doesn't actually make new memory allocation like you would normally do with inheritance, right? Because if you inherit something, if you make the inheritance, you're creating all of the aspects of the thing into the new thing, right? So
Like you jump to C,
thank you.
you jump to C language, and it's just like you make pointers, and you're actually making references to the actual memory rather than actually making new sets of memory.
So let's move on with some slides here real quick, and then we can come back. Boop, boop, and stop here. Okay. Let me get back to my slides. All right. Class syntax is sugar. So JavaScript class syntax is mostly for developer happiness. It is used. It still uses the prototypes under the hood. So this keeps it similar to. It lets you do similar things in a similar structure like Java or C#. So class uses the .prototype behind the scenes, still prototype based, not classical inheritance, and it's considered cleaner. Why is it considered?
You don't
Sugar.
use all the proto stuff.
Yes.
It looks simple.
However, there's a caveat,
Okay.
and I found this out recently as well. Just because it is sugar doesn't mean that it's exactly the same thing. If I create an object with protos and all that using constructor functions, and then I try to print out or look at the object as a whole, I'm going to see something slightly different than if I was to create a class. And that's because whenever you create a function like bark in this class, JavaScript defines it as non-enumerable. But whenever you create a constructor function and you do function.prototype.bark in this case, to be similar to this, it is enumerable. Why they do that, I don't know. Okay, so do we have time for a class example? No, let's keep moving on. If I have extra time at the end, I'll show you guys some stuff. All right, inheritance with extends. I actually didn't get a chance to super review this particular slide, so we'll see how this goes. This is how class-based inheritance looks. So basically, your normal extends capability. So if you have some class dog, you want to extend animals to include a subset of dog, then you can use it in this format. Here it says super required in constructor if overridden. I have never used super in JavaScript ever. I don't know why you would ever want to use it. But here it says that super is required if the constructor is overridden. I've also never overridden a constructor in Java.
JavaScript.
Sorry, JavaScript, you're correct. My apologies. But yeah, so
there must be some stuff that's going on behind the scenes in a base JavaScript constructor that is required if you override it, which is why they want you to call super.
I would say the same thing.
Maybe that's where it's creating all the dash proto weirdness.
Okay, next slide.
Sorry, underscore.
So there are a few gotchas to watch out for. So reference types like array and objects are shared. So I have written here, if you've ever had two objects mysteriously share state, you probably inherited a reference. And if your arrow function doesn't behave, remember it captures this from where it's defined, not where it's used. The arrow function stuff I didn't really drill down too much into, but here we have arrow functions don't bind this. So earlier, whenever I was showing you the shorthand for introducing, a function, the constructor function shape for creating a class, if you will. I included a function inside of it, and I just wrote the name of the function and the two brackets. And I used this keyword to define it back up to the name. If you use an arrow function inside of there, it doesn't understand this.
Right.
Can you make it understand this?
I don't know.
I think arrow functions, anonymous functions have trouble with the concept of this because they're anonymous functions.
Yeah. Also, do not mutate .prototype after instances are created, which is what we experimented with. So,
Yeah.
all right.
It's a weird.
Here are some helpful things to remember about object. So object has its own dot methods, and you can pass in objects to those, just like how earlier we did the array.prototypes. These are objects prototypes. So object.keys, pass in an object, it'll print out an enumerable list of properties. If you try to pass in a class, it will not print out the functions, but this will if it is a constructor function that's used. Because again, the functions in the class, when defined normally, are not enumerable. Object.values, the object will print out the values, and object.entries, the object will give you the key value pairs. And then the getOwnPropertyNames object will give you the non-enumerable ones. Why? I don't know. So those, you probably have used at least these top three a lot, especially if you work in TypeScript and JavaScript. Have you ever used these? Get property of, set property of. Obviously, we just used create.
I
So
tried to use get property of because I didn't know. Last session, you said there was a library that can tell whether it's a type of property by going through every element.
Yeah.
I had to do that, except I had to do it like on my own. So it's like I tried using get property type of, and it's
So this one,
Just for clarification, you're talking about get prototype of.
sorry, not property.
Oh,
Yes, I meant to say
prototype.
prototype. That's my apologies. But I understand what you're saying. Also, type of, the keyword type of will give you the type of something. But if you need to like dig down to get to a type, I can see how that's challenging. So here, prototype of object will give you the object's prototype. Set prototype of object proto, kind of another way of manipulating the object's prototype, but it says rarely used here. And then another one, object.create, make new object with a given prototype. And then here are some, so earlier when I was introducing objects, I kind of mentioned that they're not particularly immutable out of the box, explicitly because whenever you create an object, that static space in memory may be assigned to where the object goes, but you can add things into it, right? You can use object.freeze object and it'll say, hey, nothing in me is allowed to change. Seal is something I recently learned about. Props can't be added or removed, but existing properties can be changed. So that's useful if you want. Say again?
The values of them can be changed.
Yes.
So in that particular case, you could do object.seal first gen, and then your third gen would not have been able to override .name.
Yes, I believe that is correct. Well, no, wait, seal, it's just sealing it. So I still would have been able to change it. Freeze, I would not be able to change it. So object.prevent extensions, I've never seen that one before. That one I just kind of found. No new props. How is that different than this one here? I don't know. I guess it means that you can delete them, but you can't introduce new ones. Object.isFrozen just tells you if it's frozen. IsSealed tells you if it's sealed, and is extensible checks extensibility, which I didn't dive too deeply into. I just added it to this list.
Prevent extension sounds like you couldn't inherit from it.
We could run another experiment. How much time do we got?
No, you're good.
No, it sounds like friend extensions would allow you to inherit, and you can only have those methods and possibly overwrite them, but you can't add new methods to it. So,
Let me see if I have any fun stuff written down here. Let's see properties. Freeze, get on properties, get on. Oh, there is another one. Object.getOwnProperty define not prototype. The object define property, object getOwnProperty descriptor, and object getOwnProperty descriptors. So what those do, the first one, define property, takes in an object, a key, and a descriptor, and will define a new property within fine grain control with fine grain control. So I guess basically you're defining a property using an object, giving it a key, and then giving it a descriptor. What is a descriptor in this case? That's a good question. I'll have to look that one up. Okay. I think, yeah, I guess, unless you guys want to see more examples in code, that's pretty much it.
I know you're still just kind of looking around. I'm just Googling about it, but like Google's objects dot seal and freeze and stuff like that.
Yeah.
Like, does that translate into some type of metadata? Like, let's say I send a body of an object to a call somewhere. Would something be able to modify or change that data if I put a freeze on it in my local instance? Does that make sense?
Well, how are you is it staying within the local machine, or
Yeah, that's what I'm curious. Like, is it just relevant to your
if you're
instance?
passing it to a function within your own, if it stays within local memory,
Yeah.
then I would imagine all of its normal characteristics are there.
Yeah.
But if
But like,
you were
you
to like
set it up to an
package it up
API
as
call.
JSON, if you do like a JSON string.
So you're asking if that object carries over any metadata to tell another system, hey, I'm frozen.
Yeah.
Well, considering the fact that it has is frozen as a check, I would assume yes. But
Because like I just never see any of that unless it adds it as a prototype and it gets sent along extra.
that's a good question.
Definitely something to play with later, but
Yeah, something to think about, I guess.
You don't have anything else, because we can go back to your code and we can play around with some of this.
Sure, let's go play around with some stuff. So what did we want to see real quick?
We could
Let's
do,
see.
so you
classes,
could freeze the first gen guy, and then we could see if the
Let
third
me-
gen guy can modify it.
Go and
We're not, we can't see your code.
I'm working on it.
Okay.
Okay, so here we go again. I'm just gonna come down here. Where did we leave off? I'm going to just get rid of these. And now I have my inheritance chaining going on, or prototype chaining. And you want me to freeze? Who do you want me to freeze?
I think after line 10, so make a new line after line 10, and do a freeze on child first gen there. It's object.freeze, I think.
Oh, it's object.freeze and I pass in the thing. Okay, yeah. Object.freeze. And then I pass in child first gen. Okay.
Okay, now I'll see what it does.
Well, I haven't printed out anything. What would you like me to print out?
Oh, print out child third gen dot name.
Do I get name?
Yeah.
Child third gen dot get name. Parent.
Okay.
Which makes sense. It's just frozen. It doesn't mean it can't be copied or it can't be referenced in another object.
So change freeze to, what was it, prevent extension?
Hold on.
I think it's prevent extension. Oh, actually, let's do this first.
Prevent extension. This is a,
Okay, so line 16, change child third gen dot name equals something. And then can you let's call get name again? It may not have it. I don't know.
Billy.
Okay,
Okay. And now what would you like me to do? Where?
okay, now let's change freeze. Okay, so that works the way it looks like it should work, right?
Yes.
Okay,
So freeze the child third gen. See, you shouldn't be able to change it, right?
okay.
So, yes. So if I was to come in here and do child third, sorry, object.freeze. Child third gen. This should not allow me to do that. Yep, there's a, it's like, hey, I'm trying to do this, but I can't add a property.
Okay.
Object is not extensible.
Okay, so comment out line 16.
Ah, it's interesting. He's trying to add the property name.
after you've frozen it.
Okay, now what would you like me to do?
Okay, so change freeze up above
Change freeze up above.
to prevents extension or prevent extensions. And just see if that worked, that run.
It still worked.
Okay, so that still looks all right.
Okay.
And uncomment line 16.
Uncomment line 16.
No, we know that's gonna fail anyways because it's the same thing. Okay, so now change prevent extensions to seal.
Okay.
And that's still that, okay.
Yep, it still works. So that seal, what do we say seal did? Seal says, hold on, prevents new properties, but existing ones can be changed. So I cannot add anything to trial
Okay,
first gen.
So add under the name equals Billy, add, I don't know, child third gen dot gender equals female or whatever you want. Let's see if we can, you shouldn't be able to add a new property, I guess.
But I just added a new property here. But the only one I wouldn't be able to do is on first gen, because first gen is the only one that's sealed.
That's right.
So if I try to do this on first gen, and I hit, it's gonna fail.
Okay.
Yeah.
Property as
But
your
you-
object's not
you could
accessible.
change name on,
Right, yeah.
Yeah, I can change the name on the third gen.
No, first.
no, first gen.
For-
You could change name on first gen if it's
'Cause
sealed.
name is.
Well,
inherited.
I can't change the name on first gen because it doesn't own the property. See what I mean? So if I try to,
Or too many layers, dude.
It's the same case as with gender. We're just confirming that.
so if I do this and, I would have to try to change the name on first gen, but it doesn't own the property. So I'd have to go up the prototype chain to change the name. Yeah, I don't think it's a good way to put an example of that instance there.
But in the sense of seal, if we sealed that thing, if that was just a base object, we wouldn't be able to add.
Okay.
Yes,
Let's figure out how can we see an example of prevent extensions?
that's a good question. Let's ask AI. So it's gonna do that. It's gonna say object prevent extension. And then if I try to extend it some way, so obj dot, let's give it no, I have H,
Location.
location, sure. And I do this should not work, and this should not work because it should throw a fit. Let me comment this up here out. Okay. And then, so now the only thing that should be is this, and that should throw a fit. Yep.
This is very similar
Add property
to
location.
seal.
Yeah,
So
right.
I wonder what the
Okay, so
reason
change
was
prevent
for it.
extensions to seal. That again.
You're right, it is very similar. So what is the difference?
Question.
Sure. According to my AI here,
Okay.
prevent extension. This method prevents new properties from being added to an object, but existing properties can still be modified or deleted. Okay, so that's what I thought seal did. So let's keep going. To seal. So seal, this method prevents new properties from being added and also prevents existing properties from being deleted.
Yeah.
So I think I said that earlier.
That's it.
Very minor.
Or you said it earlier, right? So it is a very minor distinction. Why bake in that much strictness into these methods is a question I would like to know from JavaScript. Because that seems like a very small distinction given to a very similar function.
JavaScript is a giant mutated blob of stuff.
People who made it just made it up as their own one.
What'd you say?
They're still doing that.
Oh,
And they're bringing in their
like we were
friends.
doing it earlier when you changed
Some changes.
gender to we're trying to do a name.
Uh-huh.
You can't change the name because it's using the prototype field name. So it's like getting.
Okay, I see what you're saying.
Yeah, the simple piece of prevent extensions is just prevent extensions prevents from adding, and seal just prevents from adding and deleting.
All right. We're at time. Any final questions?
No, loved it. Thank you.
Cool. thank you very much for your time and your attention.
I got some closeout slides and we'll
Oops.
wrap this up. Wow.
You just plug that back in.
He was gonna leave.
Did you just disconnect everybody online?
No, the Zoom call's still going on and the session's still up. I just think is the feed still up?
No, we're good.
Okay, let me go over to
Safari, wherever that's at.
I closed it, it looks like. Is it in Canva?
Yeah, send it to
Can you
you.
try to do Command Shift T? See if you can bring that.
Command Shift D, you said?
T.
Command Shift T? A.
That's context. Let's go. Saved it. Awesome. Thank you, Gene. So appreciate y'all for being here in person. This is our closeout. So excited to have done this 3-week series. So Gene's been here this Thursday, last Thursday, and the Thursday before. I do like this format. So if you're interested in giving a talk like this online, doesn't have to necessarily be in person, but if there's something you want to talk about that you want to spend some time deep diving into, I totally have a platform for y'all available. But let's wrap this up a little bit. Some stuff I always like to call out is upcoming events in the San Antonio community. Big stuff coming on this weekend. April is a busy month. Pi Texas Conference this weekend, Friday, Saturday, and Sunday. Have a couple people that I know going. It's in Austin. So if you're interested, they're still selling tickets. They still want people to attend. So if you're interested in anything like that or just want to go network, that's totally available. You can get day passes. You don't have to go all 3 days either. But additionally, that's wrong with the logo, but we also have AI for AppSec on the same day happening Friday tomorrow, as well as a kickoff second event, I believe, for Byte Night. It might be their first. I could be wrong. Eddie can correct me later in chat. But they have their first event kicking off tomorrow afternoon. I'm excited to have that going up. Also, something I'm excited for is the San Antonio AWS meetup is rebooting. So they have their first event coming up on the 15th next week, as well as continued effort from our UXSA groups for the UX collaboration workshop. They found a lot of success last time, so they're keeping that running. Wrapping it up on some upcoming events are our upcoming events. We have Unpacking Containers happening on April 23rd, this place again. And then the week after, we have an AI agents related thing for AI April happening with web scraping and smarter summaries. So if you're interested in how we can abuse some behaviors of AI agents, come check out that. As well as another Alamo Collective event happening soon after that called Introduction to Proxmox. As I said just a second ago, big AI agents event is happening this April. So if you're interested in an AI agents showcase, build something. Come to some of the events that are happening. We're putting one on the 30th. Projects are due on May 5th with a showcase happening on May 10th. Super excited to see what the community builds. They can build pretty much anything. You can have pre-stuff. You can have stuff you make during the month. But come present it. Excited to show that off with the Geeks and Drinks group. Also, we have our June event happening, our June workshop coming up. We have pushed back this to June 21st, but it's happening on a Saturday, same time, same location. We've kind of lowered some prices, gave some discounts if you're an ACM San Antonio full member. So if you are a full member and want to attend, it is half off for you right now. If you are a student and wanting to attend, totally reach out to us. We have some additional discounts for y'all as well. As always, a big thank you to our partners, TechBlock being a primary #1, Project Cowork giving us space for a decent discount and love joining this environment. They have a great faculty, they have great teams, they have great space, so come check them out. But yeah, final thing, if it doesn't freeze, is feedback. Feedback's always important to us. If you have feedback about where the location was or how the event went or just general like what you'd like to see in the future, please give it. We're excited to have stuff like this. We're always improving. Excited to put on more events based on what y'all have or y'all are interested in. But that's pretty much it. Excited to y'all been joining us on this series. Our next meeting, our next general meeting is on the 23rd. That is our Unpacking Containers event. Like I said, it'll be here at Project Cowork, but without anything else, thanks for coming. That's it.
Thank you very much for the questions.